Hello, good evening, students. Let us try to understand the internal energy. This is the next topic from the Narayana NEET book, grade 11 from thermodynamics. So, internal energy, as per the word, we can understand that is internal energy means sum of the all type of energy possessed by any system student. So, it is the sum of all types of potential and kinetic energy of constituent particle of a given substance at a given temperature. So again you try to understand student, it is the sum of all types of potential energy and kinetic energy constituent of the constituent particles of a given substance at a given temperature. It may be chemical, electrical, mechanical, or any other type of energy denoted by the U of the system, which may be changed when. Okay, it may be chemical, electrical, mechanical, or any other type of energy. Okay, denoted by the capital U of the system, which may be changed when heat pass into or out of the system. Either heat pass into or out of the system. Work is done on or by the system. Matter is enters or leave the system. So there are three way to change the internal energy. There are three way to change the internal energy. Firstly, either the heat get in or get out. Work done on the system or done by the system. Matter enters or leave the system. There are three way to change the internal energy. So on the basis of this, we will define the first law of thermodynamics also. But let us try to understand few more points related to the internal energy. It is an extensive properties of a substance, or it is extensive property and a state function. It is a state function. It means extensive properties means that is its value depends on the initial and final states of the matter. Okay, now it is impossible to determine the absolute value of delta U of the substance. That is why it is written as delta U. Okay, because you can't get the absolute value of internal energy, so that we mention that is in the term of the delta U. Okay student, next point, let us see. But the change of internal energy of the system is delta UB can be determined. So delta U can be determined. Delta U equal to heat absorbed or released in a process at constant volume. Delta U equal to heat absorbed or released in a process at a constant volume. So again I am explaining student, delta U equal to heat absorbed or released in a process at a constant volume. So that is delta U equal to QB, that is heat absorbed or released. So delta U equal to, that is U final minus U initial. So delta U of chemical reaction is determined in the bump calorimeter, that we will study in the latter part of the chapter. For any chemical reaction, delta U is equal to delta P minus delta R. Okay, delta P is total internal energy of the products and delta R is total internal energy of the reactant. For exothermic reaction, delta U is negative, means delta reactant is greater, U reactant is greater than U product. For endothermic reaction, delta U is positive, that is U positive greater than U reactant. What do you mean by internal energy? Okay, let us try to understand again. Internal energy is not all the energy of the system. It is a kinetic energy and potential energy. Internal energy is the kinetic energy and potential energy associated with the random motion of the molecule of the object. If you heat an object, you will increase the internal energy. As the object cools, its internal energy will decrease. Next point you see student, what is the internal energy formula? This thus it is equation delta U is equal to Q plus W, means that is either heat absorbed or heat in released. Okay, or work done by the system or done on the system. That way you are changing the delta U. Thus equation they are saying here, so delta U is equal to Q plus W. If W is equal to 0, if W is equal to 0, so delta U is equal to what student? That is Q. Okay, so the internal energy is equal to the heat of the system. The value of internal energy will be negative value of the heat absorbed by the surrounding. Next point, what is the significance of internal energy? Internal energy is important for understanding phase change, chemical reaction, nuclear reaction, and many other microscopic phenomena, as the possible energy between the molecules and atoms are important. Both objects exhibit macroscopic and microscopic energy in a vacuum. What factor internal energy, what factor affect internal energy? The internal energy can be altered by modifying the object temperature, volume without altering the amount of the particle inside the body. Temperature, as the system of the temperature increases, molecule will move faster, thus have more kinetic energy, and thus the internal energy will be increased. Next one is internal energy is a state function. A state function defined as the system equilibrium state and thus define the system itself as well. For example, internal energy, enthalpy, entropy are state quantities since these quantities describe the thermodynamic system equilibrium state regardless of how the system has arrived. So if the property, if the that is the the value of is internal energy is depending on the initial and final state of the system, that is why it is a state function. Okay, so this is all about the internal energy, student. Basically you keep in mind, student, that is the internal energy is sum of all type of energy, and how you are going to change, how you are going to change the internal energy by the applying the heat absorb or heat release, work done on the system or done by the system, matter enters in or matters moves out. So this is all about the internal energy. Thank you so much for watching, friends.